Concurrency, which is a more general form of what is also known as parallelism, is the ability to do several things at once, in particular the ability for programs to do lots of things at once. And it's kind of the holy grail of programming at the moment.
Using concurrency brings great benefits for users, for example, more performance on multi-core computers. The problem is that programming concurrent applications is really difficult. The project is about a programming model called SCOOP, which stands for Simple Concurrent Object-Oriented Programming. And this programming model can give certain guarantees to programmers, which effectively shields them from making certain errors.
What characterizes SCOOP is really the S of the acronym, that is to say simple, and it's not just a slogan, it's really what we achieve by essentially taking programming as programmers know it and practice it today, object-oriented programming, and just add a tiny bit to make it concurrent as well, without having to force programmers to rethink everything and to relearn completely new techniques.
So I'm working on the dynamic and static analysis of SCOOP programs, and as well I'm also trying to improve the efficiency of these programs. Well, improving the performance of SCOOP programs is exciting because SCOOP provides you a fairly strong set of guarantees, but very often actually guaranteeing these things costs you in performance. So actually trying to get the performance back is an interesting problem.
Testing for concurrent programs is more challenging than testing for sequential programs because they include state explosion. It's because you have several execution threads that can interleave in a non-deterministic way, and concurrent programs includes more bugs than sequential do, for example deadlocks and race conditions.
We're treating the problem of finding bugs in concurrent programs as an optimization problem, applying search-based techniques to find regions of the program state spaces that are interesting in the sense that they're more likely to exhibit faults.
Concurrency is about coordinating different processes so that they do not conflict, but rather work with each other in a correct fashion, whereas parallelism is about distributing a single computation over as many processes that we can have in order to make it as fast as possible. My approach is developing concepts for libraries and programming language enhancements that enable these parallel patterns within a concurrent language without sacrificing any of the guarantees we got through the concurrency model.
There is hardly a bigger challenge than making concurrent programming work for everyone and make it safe, make it reliable, make it predictable. And our goal is to solve this number one, I think it's the number one problem open in software engineering today.